Hi everyone! Today we're going to be talking about the quadratic formula and the discriminant. Our objectives for today are that students will be able to solve quadratic equations by using the quadratic formula, and you'll be able to use the discriminant to determine the number and types of roots of a quadratic equation. Let's get started. Alright, so the quadratic formula. The quadratic formula is this formula right here. So the quadratic formula is that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, now in order to use the quadratic formula, there's steps we need to take. The first thing we need to do is make sure we write our equation in standard form, ax squared plus bx plus c equals 0, so that we can easily identify our a, our b, and our c, because then we want to take a, b, and c and substitute them into the formula. So we need to know this formula, something we need to memorize. Then once we plug a, b, and c in, we simplify and we have our solution. X equals, we can have one solution, two solutions, and they could be real numbers or imaginary numbers as well. All right, so example number 1, we want to solve this quadratic equation using the quadratic formula. So first things first, write down the quadratic formula, make sure you know it, all right? So remember, you got to figure out a way to memorize it, whether it be singing it along to the tune of Pop Goes the Weasel, like I showed you in class, coming up with a tune to help you sing it and remember it, or just plain old memorizing it, all right? You've got to memorize this formula. So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so first thing we want to do is identify our a, b, and c. So a, b, and c, what do they all equal? Well, we know a is 1 because there's an invisible 1 in front of that x squared. B is 2, and c is negative 63. Then what we want to do is plug it into our quadratic formula over here. So we end up with x equals negative b, and we always substitute things in using parentheses in case we're substituting in negative numbers. All right, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, now we just simplify. So we end up with x equals negative 2 plus or minus the square root of 4 minus, now 4 times 1 times negative 63 is going to give us negative 252. So minus negative 252 all over 2. All right, give ourselves some more space here to keep simplifying. We end up with x equals negative 2 plus or minus the square root. 4 plus 252, because minus a negative number, that gives us 256 all over 2. Now the square root of 256 is 16, so we end up with x equals negative 2 plus or minus 16 over 2. Now what we want to do is break this apart into two separate expressions because we have our plus or minus symbol. So we end up with negative 2 plus 16 divided by 2 and negative 2 minus 16 divided by 2. So negative 2 plus 16 gives us 14 over 2, which simplifies to 7. This gives us negative 18 over 2, which gives us negative 9. So our two solutions are going to be x equals, we write it in a solution set, negative 9 and positive 7. And we just solved this quadratic equation using the quadratic formula. All right, and the best time to use the quadratic formula is when you can't factor. All right, so this quadratic equation is not factorable, and completing the square would be tough. All right, and can't really solve by square roots here. So when in doubt, use the quadratic formula because it will always, always work. All right, number 3, we're not going to do it all the way out just for time's sake, but something I want to emphasize with problem number 3 is remember you have to write your quadratic equations in standard form, ax squared plus bx plus c equals 0. And this one is not in standard form. So the first thing you would want to do if you saw an equation like this would be to subtract 1 from both sides, and we would get negative x squared plus 2x minus 1 equals 0. Then you would identify your a as negative 1, your b is 2, and your c is negative 1, and then plug it into the quadratic formula. All right, so just for time's sake, we're not going to do this one because we've got a lot to cover today. But if you wanted to do this one on your own, you should get that x equals 1. All right, so if you wanted to try to do this one on your own, make sure you understand the quadratic formula. You should get that x equals 1. All right, but I really just wanted to emphasize that you have to write your quadratic equation in standard form so that you can easily identify your a, b, and c. All right, number 5. We're going to do number 5 together because it's a little bit different. So number 5, first thing we want to do is put it in standard form. So we want it to be equal to 0. So subtract 24 from both sides. When we subtract 24, we end up with 9x squared minus 25 equals 0. Now, if we want to solve this using the quadratic formula, we have to recognize that we do not have a b here, all right? There is no bx. So if you wanted to put a placeholder plus 0x in there so that you remember b is 0, that would be a good idea, all right? Or just recognize that there's no bx. So b has to be 0. And then we know that a is 9 and c is negative 25. All right, then we're going to plug it into our quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we take our values and plug them in. We end up with x equals negative 0, because b is 0, plus or minus the square root of 0 squared minus 4 times 9 times negative 25 all over 2 times a, which is 9. All right, so x equals negative 0. We just kind of ignore it. All right, goes away. Plus or minus the square root of 0 minus. Now, 4 times 9 gives us 36. 36 times 25 gives us 900, all right, and that would be negative 900. So 0 minus the negative 900 would be plus 900, all over 18. Now we keep simplifying this, so we end up with x equals plus or minus the square root of 900 over 18. The square root of 900 is 30. All right, so we end up with plus or minus 30 over 18, and we can simplify this by dividing the top and the bottom by 6. So we end up with plus or minus 5/3, and that would be our solution. So we write that in a solution set because we always write our final answer in a solution set. So x equals plus or minus 5/3, so positive 5/3 and negative 5/3. And that's our answer. All right, so remember to recognize if there's no bx, b is 0. And then you just keep solving using the quadratic formula. All right, so I want you guys to try number 7 on your own. Go ahead and try to solve this one using the quadratic formula. Remember to first write it in standard form so you can easily identify your a, b, and c. Go ahead and give this one a try. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so you should have gotten that x equals 2 plus or minus the square root of 13. All right, if you didn't simplify it, it probably looked like this, but you have to simplify it, and I'll explain why and how we do that in a second. All right, so first thing you want to do is move the 4x to the other side. So we end up with this right here, and we identify that our a is 1, b is negative 4, and c is negative 9. Then we want to take these values and plug them into our quadratic formula. So we end up with x equals negative 4 plus or minus negative 4 squared minus 4 times 1 times negative 9 all over 2 times 1. We simplify this, we get positive 4 plus or minus the square root of 16 plus 36 over 2. Simplify this right here to get the square root of 52. Now we want to write this in simplest radical form, so we look for factors of 52 that are perfect squares, and we would get 4 times 13. 4 is a perfect square. So we take the square root of 4 and we put 2 on the outside, and we end up with 2 rad 13. Then we end up with 4 plus or minus 2 rad 13 over 2. So we have to simplify this. We would say 4 divided by 2 and 2 divided by 2. All right, so the 2 divided by 2 cancels out because we get 1. So we end up simplifying 4 over 2 to 2 plus or minus rad 13. And that is our final answer. All right, if you have any questions on this, call me over so I can help you. Otherwise, let's keep going. All right, number 9. First thing we want to do is make sure it's set equal to 0. So we're going to subtract 4 from both sides. Cancels out over here. We're left with negative 8x squared plus 3 equals 0. Now we want to identify our a, b, and c. So a equals negative 8. B equals 0 here because there's no bx. And c equals 3. Then we want to take each of these values and plug it into our formula. So x equals negative b, so negative 0, plus or minus the square root of b squared, so 0 squared, minus 4 times a times c, so times negative 8 times 3, all over 2a, so 2 times negative 8. Then we keep simplifying, so we get 0 plus or minus the square root of 0 minus, 4 times negative 8 is going to give us negative 32, times 3 is going to give us negative 96, so minus a negative 96 all over negative 16. We keep simplifying things, we end up with the 0, we can just not write it, it goes away, plus or minus the square root of 96 over negative 16. Now, the square root of 96, we want to break this down and simplify it, so we look for factors of 96 that are perfect squares. And 16 times 6 gives us 96. And we take the square root of 16, and we get 4. So we end up with x equals plus or minus 4 rad 6 over negative 16. All right. Now we want to simplify this, so we can divide the top and bottom by 4. So divide 4 by 4 and we get 1. Divide 16 by 4 and we get 4. Now because we have a plus or minus here and we have a minus down here, we can just not write this minus symbol up here because it's already plus or minus. So if we were to keep simplifying this, we would get plus or minus the square root of 6 over 4. And that would be our solution. All right, if you have any questions on that, please call me over and ask. Otherwise, let's do one more example. All right, now I want to do number 11 with you because our solution is a little bit different than what we've done so far. All right, so just hang in there with me. So remembering our quadratic formula, we're going to use x equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, that's our formula we're using. We want to identify our a, b, and c. So a is negative 3, b is 8, and c is negative 7. So we want to plug all these into our quadratic formula. We end up with x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now we just simplify. So x equals negative 8 plus or minus the square root of 64 minus 4 times negative 3 gives us negative 12 times negative 7 is going to give us 84 all over negative 6. X equals negative 8 plus or minus the square root. Now 64 minus 84 gives us negative 20 over negative 6. All right, now we're going to be taking the square root of a negative number, so this is why this problem's a little bit different. So we're going to get imaginary numbers in our solution. So we break this down. We want to break this down to negative 4 times the square root of 5. Then we can take the square root of negative 4 and we end up with 2i. All right, so that's where that one's a little bit tricky, right? So we have to remember if we take the square root of negative number, we pull out an I as well. So when we rewrite this, we would say x equals negative 8 plus or minus 2I rad 5 all over negative 6. All right, now we want to divide both of these. We want to divide everything by 2, right? So we want to say negative 8 divided by negative 6. If we simplify that, we end up with 4/3, right? And if we divide the top by 2 up here, we would end up with plus or minus. We divide 2I, so we just get I rad 5. All right, so basically we divided everything by 2. Here we got 4, here we got 3, here we got 1. All right, and because these are both negative, we're technically dividing everything by negative 2. All right, so if we divide everything by 2, we end up with this as our solution. So we would write our final answer as x equals the square root of 4 plus or minus I rad 5 divided by 3. All right, and that's our final answer. So this is an example where we get I, or we get imaginary numbers in our solution. All right, so I just kind of want to review all the different methods that we've learned so far for solving quadratic equations, just so you can compare them and see the difference. All right, so our objective here is to solve this quadratic equation by all 5 methods if we can. If a method can't be used, we want to explain why. So first we're starting off by trying to solve this by graphing. So I'm just going to zoom in so we can see the graph a little better, and we're going to try to solve this one by graphing. So first thing we want to do is find the axis of symmetry, which is x equals negative b over 2a. So x equals negative, we know b is 6 over 2 times a is 1. So we end up with negative 3. So our axis of symmetry, let's not use any, let's write it like this, equals negative 3. Then we want to find our vertex. So we know the x-coordinate of our vertex is negative 3. I'm sorry, that should have been a negative up there. Okay, so negative 3 is the x value, so we want to plug it back into our original function to find our y value. So what we would do is we would say negative 3 squared plus 6 times negative 3 plus 5, 9 minus 18 plus 5, negative 9 plus 5 gives us negative 4. So our vertex is going to be negative 3, negative 4. All right, so now we've got our vertex, our axis of symmetry. So what we want to do is make a table. All right, so making an XY table, we're going to put our vertex in the middle. So we're going to say negative 3, negative 4 is in the middle. We're going to pick 3 numbers smaller and 3 numbers bigger. Or let's do 2. Let's start with 2, right? We just need enough to hit the x-axis. So starting with 2, we've got, what we're going to do is we're going to take each of these x values and plug it back into our original function. So we can use our calculator for this. So if we plug negative 4 back into x squared plus 6x plus 5, we are going to get negative 3. And if we plug negative 5 in, we're going to get 0. If we plug negative 2 in, we get negative 3. And if we plug negative 1 in, we get 0. So then we want to plot all these points. So first plotting our vertex, we've got negative 3, negative 4, that point right there. Then let's go negative 4, negative 3, this point right here. Then negative 5, 0. Other side, negative 2, negative 3, negative 1, 0. Connect all of our dots. And there's our graph. Now our solution is, where does it cross the x-axis? So the 2 points it crosses the x-axis would be negative 5 and negative 1. So if we were to write our solution to this problem, we would say that x equals negative 5, negative 1. And that's how we solve this quadratic equation by graphing. Alright, so now we can also solve this problem by factoring. So because there's no coefficient in front of the x squared, it's just 1, we can solve this by just straight diamond method. So we make a diamond, put 5 on top, 6 on the bottom. We want two numbers that multiply to 5 and add up to 6. So that would be 5 and 1. So our two factors are going to be x plus 5 and x plus 1 equals 0. Then we want to take each of our factors and set them equal to 0. So x plus 5 equals 0 and x plus 1 equals 0. Subtract 5 from both sides. X equals negative 5. Subtract 1 from both sides, and x equals negative 1. So therefore our solutions are going to be x equals negative 5 and negative 1. And that's the same solutions we got when we solved by graphing. Alright, now if we wanted to try to solve this by square root property, we have to recognize that we actually can't solve this by the square root property. In order to solve it by the square root property, we would have to complete the square, which is our next method. Alright, so the reason why we can't solve this by square roots is because there's a bx here, right? If we're solving by square roots, it has to be in the form ax squared plus c equals 0. Because there is a bx, we cannot solve this by square roots. So we would write cannot be solved by square roots because there is an x term, all right, or there is a bx. All right, so recognizing that we cannot solve this by square roots. All right, so we can't solve it by square roots, but we can solve this by completing the square. So what we would do in order to solve this by completing the squares, the first thing we would want to do is subtract 5 from both sides. So then we would write this as x squared plus 6x, and we're going to leave a space, equals negative 5. Then we want to take our b, divide it by 2, and square it. All right, so we end up with 3 squared equals 9. So we want to add 9 to both sides. When we do that, we end up with being able to factor this side right here because it becomes a perfect square trinomial. So two numbers that multiply to 9 and add up to 6 would be 3 and 3. So we end up with x plus 3 times x plus 3. And then simplifying this side right here, negative 5 plus 9 equals 4. We rewrite this side as x plus 3 squared equals 4. And then we now can take the square root of both sides. So when we do that, we end up with x plus 3 equals plus or minus the square root of 4, which is 2. Subtract 3 from both sides. Cancels out over here, so we're left with x equals negative 3 plus or minus 2. And then we write this as two separate expressions. So negative 3 plus 2 and negative 3 minus 2. This gives us negative 1 and this gives us negative 5. So our solutions are negative 5 and negative 1. So we just solved this by completing the square. And we got the exact same solutions as we did when we solved it by graphing and factoring. All right, and last but not least, we can solve this problem by using the quadratic formula as well. So we identify that a is 1, b is 6, and c is 5. And then we plug it into the quadratic formula. So x equals negative b, negative 6, plus or minus, I'm just going to scoot this over so we have some more space here, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Simplify things down, so negative 6 plus or minus the square root of 36 minus 20 over 2. Negative 6 plus or minus the square root of 16 over 2. And we can take the square root of 16 and we get 4. So negative 6 plus or minus 4 over 2. And now we want to write this as two separate expressions. So negative 6 plus 4 divided by 2 and negative 6 minus 4 divided by 2. This one gives us negative 2 over 2, which gives us negative 1. And this one gives us negative 10 over 2, which gives us negative 5. And what do you know? Those are the exact same solutions as we got when we solved it by graphing, factoring, and completing the square. So all of those methods will give us the exact same answer. All right, so when we're trying to decide what would be the best method for solving, we always want to ask ourselves, factoring first because that's usually the quickest, and then if we can solve it by completing the square, great. Square roots is usually a quick method, but when in doubt, quadratic formula will work. It just usually takes a little bit longer. All right, and graphing is usually our last resort because that takes a lot more time. All right, the last thing I want to talk about is the discriminant of a quadratic equation. Now, the discriminant of the quadratic equation, we can find it by using a formula. So the formula for the discriminant is b squared minus 4ac. All right, so basically the discriminant of the quadratic equation is what's inside the square root in our quadratic formula. All right, it's the b squared minus 4ac. All right, now if we use that formula, b squared minus 4ac, and we find the discriminant, it can tell us a lot of information. So the discriminant can tell us how many roots there are and what types of roots they are. So it's really important that when we find the value of d, we're able to identify this information. So this table we're about to go over is really important, and I would know this table if I were you. All right, so what information does it provide? If we find the discriminant and we see that it's greater than 0, so we know it's positive, and it's a perfect square, so it's 1, 4, 9, 16, 25, 36, 49, and so on. So if it's positive and it's a perfect square, that tells us that there's going to be 2 roots, and both of those roots are going to be real and rational numbers. Now, if we find the discriminant and it's positive, but it's not a perfect square, that tells us there's going to be 2 roots, and they're going to be real, but they're going to be irrational. Now, if we find the discriminant and it equals 0, so if the discriminant equals 0, that tells us that there's going to be 1 root, and just a reminder, root is the same thing as x-intercept, solution, 0, all different names for roots, right? Roots are where does it cross the x-axis? That's our solution. So there's going to be 1 solution if the discriminant is 0, and it's going to be real and rational. And last but not least, if the discriminant is less than 0, if it's negative, that tells us that there's going to be 2 roots, and they are going to be imaginary. All right, so, and also just a reminder, irrational means it's going to be like a square root or an ugly decimal. Rational means that it's either a whole number or it's a fraction or decimal that terminates or ends. All right, so just a quick reminder on the difference between rational and irrational. All right, and obviously imaginary means we're going to have an I in our solution. All right, so know this table. This table is very important. I'm going to start again. All right, so what we're going to do for these few examples is we're going to find the value of the discriminant and then determine the number and type of roots. So first thing we want to do is make sure it's written in standard form of a quadratic equation, so ax squared plus bx plus c, and it is, so we're good. Then we want to identify our a, our b, and our c. Now we want to use the formula to find the discriminant, which is b squared minus 4ac, and we want to plug these values in. So we get 12 squared minus 4 times 2 times negative 13. So we get 144 minus 8 times negative 13, and then 8 times negative 13 is going to give us 104. So that becomes plus 104. 144 plus 104 gives us 248. All right, so 248 is the value of our discriminant. Now 248 is positive, but it is not a perfect square. So that tells us because our discriminant is greater than 0, it's positive, but it's not a perfect square, we are going to have two roots, and they are going to be real and irrational. So we are going to have two real irrational roots. And we're done. All right, number 3. Before we can find the value of the discriminant, we need to write this quadratic equation in standard form. So it has to be equal to 0. Subtract 10x from both sides. Cancels out over here, so we're left with negative 4x squared minus 10x plus 84 equals 0. Then we can identify our a, b, and c. So a is negative 4, b is negative 10, and c is 84. Now we want to use our formula for the discriminant, so b squared minus 4ac, and plug our a, b, and c in. So we get negative 10 squared minus 4 times negative 4 times 84. We get positive 100 plus 16 times 84. Plus 16, positive 16 times 84 is going to give us 1,344 plus 100. We end up with 1,444. So that is the value of our discriminant. And believe it or not, 1,444, if you plug that into your calculator, that is a perfect square, all right? 38 squared equals 1,444. So 1,444 is a perfect square. So it's greater than 0, it's positive, and it is a perfect square. That means we are going to have two real rational roots. All right, so it's really important that we know that table that we just went over. That's right above these problems in your notes. All right, so know that table. That tells you what is the value of your discriminant, how many roots you have, and the number and type of roots. All right, last but not least, I just kind of want to go over this little table right here, and this kind of quickly summarizes how you can choose the best method for solving quadratic equations. All right, so we learned 5 methods: graphing, factoring, square roots, and completing the square, and quadratic formula. So when can we use these, and when's the best time to use these? All right, so I'm just going to zoom in as we fill out this chart. So graphing. Graphing can be used sometimes. All right, not all the time, but we can use graphing sometimes. And it's best to solve by graphing when the roots are integers. All right, so when we know that the roots are integers, that's when we want to solve by graphing. However, solving by graphing is usually not practical, all right? So not usually the best method. But it can work. Then solving by factoring. We can do this sometimes, not always, because we can't always factor a quadratic equation. And this is best when roots are rational. So if we were to find the discriminant and we knew the roots were rational, factoring would be the best method. Solving by square roots. This we can do sometimes, and we kind of went over when we can't do this already. So we can solve by square roots when there's no b term, all right? When there's no b term or x term, all right, then we can solve by square roots. Now we can solve by completing the square always. So this method will always work. And the best time to use this method is when there's no coefficient in front of the x squared. So there's no x squared coefficient. There's no a. All right, then it's easiest to use solving by completing the square. And if our b term, so if the b in front of the x, if that b term is even, so if we have an even b, that is going to be a lot easier to solve by completing the square. If it's odd, we're going to get a fraction and life will be challenging, all right, because we have to be able to divide it by 2. And if it's even, we're able to divide it by 2. Then, last but not least, quadratic formula. So quadratic formula will always work. So when in doubt, use the quadratic formula. It'll work anytime and every time. All right, so use this when you're not sure what other method to use. All right, so use when other methods or other situations are inefficient. And I'm trying to fit this word in here. So when in doubt, use the quadratic formula. All right, so this little chart kind of helps explain when we can use each method, all right, when it can be used, and when is the best time to use it. If you have any questions, please be sure to ask me, all right? So I hope you learned a thing or two about the quadratic formula and the discriminant today. I know it was a lot of information for one day, so if you have any questions, be sure to call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye!